Hi, everyone.
Hey, lad.
Hey, morning.
Morning.
Uh, is Boppy the OCP host, or is that someone else?
Oh yeah, it's me.
Okay, great.
That's I now have the power to mute people and kick people off, and like it's just getting to my head. Hey Kevin,
I have this.
if you're still on for this Friday, could you please send me an abstract of what you'll cover? Usually, having an abstract tends to get a slightly larger audience.
Okay.
3 lines, nothing fancy, just 3-4 lines saying we're going to talk about this. That's about it.
Right. Well, and I think your request is that we talk about the scope of standardization, right?
On Friday, yes. Like this is the project we want to work on. This is the problem. This is the project, and this is the and we're going to deliver this, and I don't know, making up an X months the target. Our today I think it's Kash with his with a follow up on the 4-8-bit, and then a continuing discussion on the scope that we had last week. Those are the two that I remember.
Okay.
Kash, you want to go first or second?
I'll go second. I have to wake up.
Okay, Kevin, it's all yours then.
Okay.
So yeah, yours. To continue
So
the scoping discussion.
you wanted me to send you an abstract for Friday's talk, which is basically about this about the scope of what we want to standardize. I have no idea how to estimate schedules or times or anything like that.
Oh, that's fine.
Um,
It's more like this is what we're going to work on. That's it. We
Right.
we want to kick off an activity and on this, and you're welcome to join us if this is of interest to you. That's the main intent of the talk. On Friday, right? That's what we're talking about. The Friday. Do we lose Kevin?
no, you didn't lose me.
Hmm.
Yeah, on Friday. This is
And
what
for today, I thought we were in the middle of a scoping discussion last week, which kept going and going, and that we would want to complete it today.
Sure. I'm not sure that I can complete it. So I'm working on slides for Friday. I'm sharing one right now, which I'm sure you can see.
Yep.
So this is what I captured from last week's meeting. There were 3 elements. The first being use cases. And then 5 proposal and a potential link layer to go with the 5 proposal. This is the 1, 2, 3 that I think you listed. Is that fit your expectation, Boppy?
100%.
Yeah, that's what I figured. So from my standpoint, by the way, I've been out sick. I actually had COVID, so I'm trying to catch up here.
Oh my, you're like the second or third person.
I have not met with Ramin yet. I know that link layer is something that we're not sure what we're going to do yet. And I'm glad Elad's here because I wanted to talk about a couple of things. But so first, on the system level use cases, there are a couple of obvious ones. So you could think of a DDR5 chiplet, which is one of the aspects of UMI. And you could think of something at high end as a HBM like use case. As Elad said last week, people are already building DDR5 or DDR chiplets running AXI over a standard Bow 5. It's not clear that we need something different to accomplish that. Not sure I'm putting words in your mouth, Elad, but that's what I heard you say last week.
Sort of, yeah. I mean, I think there isn't necessarily any new I'll call it low-level spec work that's needed. In fact, maybe not any quote unquote spec work at all. I think the only thing we would want to do there is just standardize. Well, standardize meaning in the sense of either provide recommendations or quote unquote requirements under a new standard. But yeah, I think the only things we would need to do there are just say, okay, here are the actual AXI configurations. Here's, sort of how many like slices wide, each link layer should be connected to. Here's how many transmitters and receivers. But yeah, so I mean, I think there is some actual technical work there. It's just not necessarily, we don't necessarily have to define a new PHY or define a new, sort of link layer. We just have to give the parameters for those that people should actually use.
Wait. That is if you're using an AXI interface, but we also had a fairly robust debate on whether it should be the DFI or the AXI interface, right?
Yeah, no, and just at least I think Kevin will probably say this in a moment too, but at least my pitch would be that I think both should be done.
And it's not clear that if the DFI is the one to go, that our current link layer works.
Yeah, but just to be careful, I mean, I think at least, again, Kevin, correct me if I'm wrong. I think we've seen that, that there are cases where you want to do one, there's cases where you want to do the other. So you might as well just cover both.
Right. So maybe if we're going to do AXI as the interface, the link layer as we have, it really becomes a use case. This new thing becomes a use case. But if you're going to do DFI, there really is some sort of ground up work on whether the link layer that we have is adequate, right?
So yes and no, like how should I say? Okay. So there's and there's sort of, let's say, caveats I would offer on both sides of it. So on the quote unquote, yeah, you're going over AXI and it's a use case. As we discussed, I think, both offline and in the past, right, there are some games people may want to play specifically knowing that they're going to be talking to a memory chiplet that, it's not that the standard doesn't support them, but, if you don't explicitly say it, then people wouldn't know that, that they should or could be doing that. So for example, having more transmitters and the receivers, which style of AXI do you use, how much bandwidth do you actually allocate, right? There are a number of these things that just are design decisions that, even though there are, they all fit within the existing specs, they just still need to be decided and communicated one way or the other. So that's sort of on that branch of things. On the quote unquote DFI, if it was literally carrying the DFI protocol, you just need the interface profile with the existing link layer. But I think I was using that as a little bit of a shorthand that's perhaps inaccurate, and I think I believe Kevin is also sort of thinking this way too. And that if on the other hand the data interface is more sort of almost replacing the DDR IOs, maybe not literally, but sort of is conceptually akin to that, then definitely that's a different PHY, and what the link layer for that PHY looks like is I guess, having not thought that through, there is an open question there, at least for me. Kevin and others may have more thought there than I certainly have.
So, excuse me. So, the way I'm thinking about this is two use cases, and I understand what Elon's saying is it's possible that we start I don't know if this is the right word, but like a standardization umbrella effort that has two different types of use cases. One, which is running AXI configured for DDR that's not trying to do anything else. And that's more of just a use case of existing things. And the second is something that's trying to be able to tackle bandwidth such as HBM. And that would be, would result in a different PHY. That could also be used for a DDR chiplet. That was the concept of UMI, but that is an effort that has more elements involved. I'm not sure if they both fit under this same umbrella. And I'm not sure that we want, what I wanted to do today was try to understand how to go into Friday. Do we propose some broad thing that allows us to do both or either, as we choose going forward? I'm assuming by the way, Poppy, let me step back. I'm assuming the Friday is like an umbrella ODSA meeting from which then the work will just continue after that, you know, in this meeting and the link layer meeting or wherever substreams make sense. Is that the right kind of hierarchy?
Yes.
Yeah, that's what I thought. So
So-
your thoughts on whether we should be trying to set a broad umbrella that encompasses more than one effort?
Yes, my bias would be to just say this is the universe. This is the problem we're trying to solve, and this is the universe of solutions we will explore. And we might not end up doing all of them, but this is the range of things we want to do. We could do at least.
Okay. I
Yeah,
understand.
and maybe just to, you know, both help and clarify, you know, yeah, like as I think we're all saying, you know, that it could indeed be multiple parallel efforts, or for sake of, you know, let's say quantization, you know, one effort on, for lack of the better word, the DFI version, or let's say the more intimately linked to the, you know, sort of to the DRAM IOs. And then the other where, yeah, there is a memory controller on the other chiplet, and, you know, you really are using AXI. You know, so I think, you know, both of those are large, you know, very parallelizable kinds of things, and I'm happy to help, you know, drive the AXI one, since the other one has, you know, I think already has a great driver.
Got it.
And I think the only other one that I was gonna, or the only thing I was gonna mention was, you know, at least in my mind, and, you know, maybe that's for reasons that I just haven't gotten to yet, but in my mind, I think the split between the two is more related to, yeah, just I mean, maybe the simplest way to say it is, yeah, just is there a memory controller embedded or not? Because if there is, then I think it sort of, you know, boils down to the AXI case, and if it isn't, then, you know, it'll be much closer to the quote unquote DFI case. Whether it's literally carrying DFI or not, obviously, is somewhat of a different question. But yeah.
Yeah, so I understand your point, and I think that's a logical point, but that's not actually how I look at it. And it's actually simpler than that. It's more related to the physical PHY. So if regardless of where the memory controller is, if the memory controller is, if the memory controller is on the chiplet side, just take that for a second. If you use fixed unidirectional lanes, you can run AXI, because AXI requires that. But if you want to run a bidirectional, dynamic bidirectional PHY, because it's much more pin efficient, AXI doesn't support that. So you need a modified AXI, or you need some other thing that's not AXI and it's not DFI. That's the case that I think ultimately I want to look at. But again, if it's an umbrella and there's multiple cases, we can get to that over time.
Yeah, so I guess maybe, and I'm sorry, I might have just blanked for a second. So you're saying that if there is no memory controller, or you're saying independently of memory controller or not,
No.
you wanted to look at the bidirectional case just to sort of see. I'm rephrasing things in a way that you didn't say, so I'm doing it to see if I caught it correctly.
We had this debate last week, so I'm going to flip to a different slide. Can you see what's on my screen right now?
Yes.
So this is straight out of the spec, and this is straight out of the normal configuration. You got a bunch of receivers, you got a bunch of transmitters. And there was a debate last week about what happens with bandwidth when you're bidirectional. Somebody thought bandwidth was cut in half, somebody thought the bandwidth is the same. So aggregate bandwidth, if you make all these bidirectional, aggregate bandwidth is obviously the same.
Yep.
But in a memory case, the read or write bandwidth is double versus the fixed unidirectional case. That's what I'm trying to show here. And I created this to try to address the debate we had last week. Does this make sense?
Yeah, no, this part definitely makes sense. I think
If you're beachfront limited and you're trying to get as much read or write memory bandwidth, you may want to use bidirectional IOs, even if the memory controller is in the chiplet, strictly from a maximizing beachfront bandwidth standpoint. But if you do that, you can't run AXI as defined. That's
right. So okay, yeah, totally agree.
So when we talk about the PHY, I wanted to be able to set up the background so we understand why it is interesting to consider this dynamic bidirectional case. totally understand the point you're making that if you're running, I don't think if you use a dynamic bidirectional, you're going to use AXI. But if you use our fixed unidirectional or configurable bidirectional, excuse me, you could run AXI, and that is what Boppy called a use case that requires, could require some documentation in order to make Bo more effective in that. And I think that is one effort that could happen under this. The second effort would be creating a dynamic bidirectional PHY, and either you're running DFI or you're running something that's neither AXI nor DFI, depending on where the memory controller is, if you have a dynamic bidirectional PHY. I guess maybe
Right,
that's
no, makes sense. And I think, by the way, we're probably, I think we're saying the same thing at the end, obviously, perhaps.
I'm just trying to rephrase it so I can think about
Yep.
how do I do what Boppy's asking me for, which is send him an abstract and propose a scope. So that.
Yeah,
that-
no, makes perfect sense. Yeah, and should say this. I kind of like the way you phrased it in the, yeah, I think what you're describing is sort of it is some new interface, because yeah, it's not really, it probably won't really be a DFI, and it's definitely not AXI. It's probably something slightly else. And that's what I was attempting to describe by something, sort of closer to the quote unquote DDR5 IOs, but I'm the first to admit that description is not particularly necessarily clear. So yeah, but I think we're talking about the same thing, just obviously naming we'll have to figure out.
Yeah, and we'll figure it out. Yeah, I think you started down the path of, it depends on what the memory controller is, which is one way to think of it. I was starting on the path of, it depends on whether the PHY is bidirectional. If it's bidirectional, then it can't be AXI. And if you want the memory controller to be on the other side, then you're gonna have to do something else. And that's where we are. So I'll
Yeah,
keep
no, it makes
looking at
sense.
that. Boppy, I think that is where I am, at least right now, as far as scope. And I heard you want me to send you some kind of abstract.
So
Okay, so I'll do that.
I based on our conversation, I think there is a fourth scope thing that
Okay.
I think this is one of those cases where the output is also a prescriptive configuration document that glues all of this together. So if you're going to try to talk to HBM, or if you're going to try to talk to LPDDR, we need a fairly prescriptive configuration document. Kind of says this is the PHY, this is the. I think I'm asking. So when I listen to everybody put together, say if you want
I
to talk
don't know. So normally you have the PHY proposed PHY changes. Let's say for the AXI case, there aren't any, but there's a configuration. But for the bidirectional, there'd be a proposed PHY change. So I assume that goes in the PHY spec. And a link layer change would go in the link layer. But there's a third document called a configuration document that describes both. I'm not aware of that. So
No, so when I say configuration, I don't mean just these things. Like if you're going to build a memory interface for 64-bit, or for HBM3, your PHY has to be this wide. Your link layer has to the whole thing glued together for a specific memory. We'd have to, right? In some sense, if you're going to talk to a HBM, this is how you do it. If you're going to talk to, say, LPDDR, this is how you do it. Wouldn't we need to put something in?
I understand what you're saying, but is this something there's examples of these that exist today?
No, you'd be our first victim.
Well, I think Elad would be our first victim. He's got this in mind. So Elad, since you're talking about the AXI case and it's a certain
Yeah,
width.
no, I was gonna take that sword from you anyways, or whatever. Take the blade
How does it get-
from you
how
on that
does
one
that get-
anyways. So yes.
But how does that get
This is one thing I'm happy to help on as well. But the sort of it is one thing I think for this you're going to have to glue things together in a way that we haven't had to. We've been thinking
Yeah,
about
no, that is correct, and yes, not to put it, whatever, not Kevin's problem. We'll obviously we're happy to have all the input, but yes, you and I can own that, Bobby.
Yeah, but look at that. You're my first victim sounded so good.
Well, it's just we are our own first victims.
Our own first victims, yeah.
Yeah, we've been trying to figure this out for a generic use case, but I think this going for memory is a much better first use case, maybe.
Okay. And so
So in this, I have a question. What should we target? Should we just start with HBM or should we start with two kinds of memory?
No, I think we need to start with at least the use case Elad outlined, which is, say, a DDR memory chiplet. The bandwidth is modest and can be handled with bow unidirectional. Maybe there's some configuration changes like 2x the read versus write bandwidth or something, but and link layer configuration. So we start with DDR that uses a configured bow, and then we start with, and the second would be like an HBM that requires, it just can't fit in the beachfront required using unidirectional links, so we have to go down the bidirectional. So it's DDR and HBM. I think there's two use cases.
Okay. So any particular bandwidth we want to target, or we'll figure all that out along the way. So DDR and HBM for now.
I think for Friday, we'll figure that out. Yeah.
Okay.
Yeah, I think we'll end up, it'll end up being, in that case, it'll end up being quantized on AXI channels. So I think there's a simple unit to refer to there.
Okay. And so I had an HBM use case, and from the ODSA from last week, 2 weeks ago presentation, there was a DDR use case. So we can show both on Friday as examples. I mean, I'm assuming we're trying to set the table, not, solve the problems and give all the answers. So we're just trying to be high level on Friday, right? Bobby.
Meaning? Sorry, I didn't understand the meaning of the.
So on Friday's meeting, we're trying to be pretty high
yes.
level, not deep dive on them. But I have a DDR use case and I have an HBM use case.
Yeah.
So those are good.
Yeah.
Okay.
And I thought that there was one, at least in the conversations I've had, I thought you would also need something like the Phi proposal would also end up using some portion of what Kash and Ahmad are talking about and Marek were talking about smaller than 8-bit, 16 and 8-bit Phis, because you have this weird memory width for DDR and things.
Yeah, I think less so in the AXI case, because it's quantized on AXI
Right.
Chunks, but
Yeah, so
but in
that distinction is
something
worth
that's
calling
more
out.
DFI based, or in our HBM proposal, it is certainly not by 16, or by it's usually by 18s, and then there's by 18 of bidirectional and a few unidirectional, more going to the memory than coming back. Even it's asymmetric, so it's a combination. You're right, of a smaller than a standard Phi with the addition of bidirectionality. So I don't know what it will look like exactly. I mean, I think we'll have to go through that in meetings, but it is a combination of probably multiple things will come into the Phi define definition.
By the way, Kevin, can you remind me the by 18? I don't recall. It's actually by 18 data, or it's like DMI and something else.
So traditionally in HBM, so they have ECC bits, and but ECC bits are not what you think. They're not error correction, because there's a bunch of ECC inside memories that's all hidden.
Yep.
From users. This is actually just metadata. So the CPU generates it. It's really just extra data that gets stored in the memory and read back. It has to a Phi, it's just extra bits. You don't do anything with it. They also have in DBI and parity checks. Those don't translate to a data-to-die interface necessarily. So, and if you look at an HBM spec, it's not it's a really strange number of bits that get transmitted because of the way the bus is configured. But if you think about just pure, what are the data that are getting sent and then on a write and read, it's by 18.
Got it.
So Ela, I think that the two things are going to end up being way more different than we think they are at this stage. Or I believe, maybe two
The-
things.
No, I guess, well, I think they are quite different, but I thought that from the beginning.
Yeah, exactly.
Well, you didn't act like that. All right, fine.
No, I wasn't, so when we started this conversation last Wednesday, I was thinking of the HBM case because that's what Ramin was talking about. And Eli brought up the DDR case. I think they are very different. And I think putting them both under this umbrella is a good idea.
So that one discussion, that one point is worth bringing out to a larger audience. So I don't want to leave you the wrong expectation that this is somehow some magic thing. This is, at least for us, is for us to sort of clarify our own thoughts. But calling that distinction out is a good thing. And I think that if that's about the only really big one that has a stick in my mind. And hopefully we get a few more fellow travelers because of the meeting. If not, it's something to help us clarify our thoughts.
I can put them as examples, or do you want me to say these are the two were?
Oh, no, not this, I didn't mean, these two, yes, but I also meant the two orthogonalities in the approach, which is one is an AXI and one is a, the direct memory, a DFI type interface. These two are important too. And
So for Friday, I'm assuming you're hoping for a half dozen slides or something small and
Yeah.
keep high level.
yeah, either it attracts a lot of discussion and we have, we those 6 slides keep us busy, or the whole thing just gets wrapped up in 20 minutes and we're back to.
I'm assuming there's going to be a collection of people that don't have any idea what, so I threw a couple slides from the OCP presentation so that to set the table, but yeah, I'll try to keep it concise and short. I'm hopefully meeting with Ramin today if I can catch him to go through it. I'm back in the office first day, so
Wow,
it's good.
all this from the OCP?
This was, I got sick after OCPs, but it's been, yesterday was day 10. I was sick last Wednesday when we talked, so that's why I was
Wow.
barely coherent. While you were throwing all kinds of things at me, but that's okay. Life's good. I'm feeling much better.
I'm happy to hear that.
And it's way, the second time was not nearly as bad as the first time, so thank God for that, because it wasn't that bad. All right, that's all I have for today, I think. So do you want to go to your second topic?
Yeah. Kash, this is what I was referring to as saying, I thought there's room for more fellow travelers for you to accumulate them, and Marek is here as well.
Okay, just let me figure out how to share my screen, and then I have to figure out to share the right screen. I think Are you able to see my screen?
Yes.
Okay, so I think that the last meeting, which I actually missed, I think Ahmad was like, hey, the feedback was, hey, there's different points of view. Obviously, one is obviously just, the advisability of keeping the 8-bit standard as is. And I think we've internally talked about it and said, I think that's maybe a good idea because there may be people already designing for it. It's been out there for a while. And so maybe an addendum, which is a better way to go. And so now that potentially could give some flexibility, more flexibility, as we discussed. And the other thing from when I look at it, how we would actually realistically implement it is we would want to, on the host side, maybe have a 16 lane or 8 lane. I still don't know exactly which, but the IoT could be as low as 4 and go to 8. So we want to have some sort of flexibility on that. And so I think on the end device, it's much easier from our standpoint and we know that with the single clock that the clocking is critical. So we really want to try and keep this symmetric clock in the middle. So we can do that with calling it an addendum, right? As I understood it, right? So here's an addendum where we can say, hey, we deviate from that, putting the clocks on the side. So that's, I think, the approach that we would like to take. And we note, and I think Elad sent a note that you've seen issues with the single clock, right, approach, right? And certainly I'm sensitive to that because until we've all implemented it or try to implement it, it's really hard to say. So I just added an extra note, which is we may need to have an option to run below 2 gigs. So right now, 2 gig bow is the minimum, right? As I understand it. So if we find as people implement that there's a need to run at a lower speed to support lower power or something run unterminated, then I just want to propose that as something we at least have as an option. Sorry.
So sorry, there's one thing. There is one thing we have a larger discussion with both you and Kevin or everybody. Are these things going to be derivatives or modes? I don't think we ever created some. We were sort of that's one thing we sort of split on last week. We never closed whether we wanted to make these new things derivatives or whether we want to make. And I think that we sort of have been implicitly defining a mode as something that where you can all the other modes it can interoperate with them. But a derivative is something that is derived from, but you're sacrificing interop.
Yeah. Well, I think that's a great question. Right. So I sort of addressed that in a way at the bottom, right? So in theory, let's say that you have a bow 5 plus. I'll just use the word plus for lack of a better name, right? So I think it would be desirable for folks to be able to support the standard bumps pretty much as is, and potentially also be able to act as a host, for example, right? And then endpoints can connect to that. So I think that that's a desirable option. Whether we run into a whole bunch of issues when we implement it, who knows, right? And I think that's, but at least that should be the goal, right? So we may end up, hey, we can't quite make it just a mode. It has to be a derivative, but I think at least one goal should be that we should enable ideally a mode where it can connect with, you know, that 16 lane or let's say it was a 16 lane phi. It couldn't just connect to these derivatives. It could potentially also, you'd want it to connect to a standard bow, even if it was only at 4 gig or 8 gig or whatever, and couldn't do the full thing, because there's always going to be a compromise, right? So that's part of the challenge here.
In general,
yeah.
Sorry, I was just gonna say, I think that makes sense. I guess, Mark, what's I'd love to hear your thoughts. I guess, as far as I recall, sort of the primary motivation of the clock in the middle, clock on the sides originally was just to sort of like simplify a little bit of the remapping that might need to happen. You know, if you had the by 8 talking to the by 16. But yeah, I've certainly seen cases where, you know, the clock ended up needing to be in the middle for just other practical reasons, even on the by 8. But yeah, I don't know, Mark, I'd love to get your input.
Yeah, no, I mean, good question. I think like when we were working on it for the by 8, I think the only reason we didn't put it in the middle was this idea that it would be easier from kind of a like higher up level to just say that you don't have to, that you can say like you get the first 8 bits and then you take two of those code words and then it's like a 16 slice again. But in terms of like actual implementation, I can see that it's easier if it's symmetric. So it's a little tricky now that we've made this decision for bunch of Wires 2.0 how to consolidate that with this. Otherwise, like the by 16 definition and kind of the being backwards compatible, I think that should be straightforward to at least proclaim that we want it to work that way.
Yeah, so I guess there's sort of potentially two issues that you're touching on, which I think are the right ones. One is just sort of, okay, technically speaking, what would it take to make things work? If we sort of went the other way. And I think the implication is that there's some more muxing or something that has to happen sort of inside the guts of the FIs. And, as annoying as that is, I don't think that's too terrible. And then the other is just, okay, well, we have something that's in the spec right now. And, if we decide to make a change, then obviously, that has changed in the sense of, either redo what we said previously or add extra stuff in. And yeah, we'd have to decide which way to go and whether or not, there's other fallout that we're worried about from doing so.
Yeah, exactly.
So I guess
Mark,
maybe
I certainly take the point you did beat the standard, and then now trying to change it if in the case somebody's designing for it is problematic, right? So you just say, hey, you changed it after 6 months, so it's kind of that's why I was just thinking maybe it's better to keep it as a sort of a derivative, or I don't know. I mean, I don't have a
I think that's
hard,
fair. I think maybe I think I like the strategy in the sense of, yeah, we can just leave the thing there as it is, and then just say, okay, hey, look, like here's an alternate order that that is whatever, as you said, a derivative or whatever we want to call it, and and just explain that alternate order and say that it's not expected that alternate order interoperates with non-alternate order, but but both are formally approved or whatever we want to call it.
right. So I think that this sort of, as a politician, it finesses the issue,
Right.
right. So and as engineers will end up utilizing to a certain extent what they want or what makes sense to them, right? So, and if
right,
customers saying, hey, we really want it on the side, well, heck, we're going to implement it on the side. And I think you also mentioned, hey, having maybe extra clocks or whatever, right? So I think that was something we discussed as well, right? So in case we do need, and again, that's something that should be part of the discussion as we actually start to implement this, right? And say, what is it going to be the exact pin out and so on. That and obviously you want to try and maintain this. And now taking into account what I've heard from Kevin and this UMI, my sense is that, this 18 bits, if it really makes a big difference, and intuitively it would, then I haven't actually talked to Ahmed about this, but my sense is it would be really nice if you could just say, hey, this also supports the 18 and just make it 18. But that's just my initial sense, because you don't want to have too many variation, approaches, right? So anyway, so that's the UMI hasn't even taken off, but I'm sure it will.
Is it simple? I mean, okay, this is more like before Elad will kill me on this, but is this a sort of generic spec of clock in the middle, arbitrary number of bumps to either side, symmetric up to a maximum?
Yeah, that's kind of how we've put it in our sales bullshit, right? Sorry for the French language, right? And obviously actual implementation is always harder, right? So obviously we're not really going to do much less than 4, and 8 will be the most common one, I would think. But I certainly see, some people wanting 16 as well, right? Where they may do 12 in one direction and 4 in the other, for example, right? So I do see this standard not just being for 8 bits, that for sure, right? So having flexibility there. I don't know if you could take it to 32 bits or anything crazy like that, but I certainly see up to 16 or 18 or something would be okay. Should be okay.
But the 8-bit slices we've defined are all unidirectional, right? Or do we also say a configurable?
The way the spec is written right now, there's nothing stopping someone from doing a configurable directional 8-bit slice.
Can you also
Right,
do
those are
the,
sort of
I think you
two
can also do a
independent
16, right?
options, so to speak.
Lad, you can
I'm
still
sorry.
do, you could also do a 16.
Correct.
Yeah, there's nothing in the standard that ties it to 8 bits. You can do
Right,
the
exactly. Basically, the
bidirectional
configurable
16.
directionality thing is sort of a bit you can flip one way or the other independently of everything else.
Right.
But do all 8 bits are configured the same? Is that how it works in the spec today?
I think so, yes. Maybe just to clarify, the assumption is it's configurable directionality, meaning that, oh, I see. Now I understand. Yes, right now there's nothing in the spec that would talk about individual lanes inside of a by 8 being configured differently. That is true. And I think, that as I
That's
don't
part
remember
of
when
what-
it was, but a few weeks back when we talked about it, I think that's a reasonably simple extension that would be interesting.
And that's, I think, what your chip brought in.
Right.
Right.
Okay.
So at some point, somebody, we'd have to make a decision on simply saying, okay, here's a new bow mode, and you just have sort of a compatibility matrix of bow modes and say it's expected to be compatible with this and not with the others, and either operate that way or call it a completely new phi. It's derived from bow, but we're picking and choosing, and this is a new set of modes which are guaranteed compatibility in this new phi. We have to choose one way or the other in my mind.
Well, I think basically everything up to basically using the same clock, on both sort of the transmit and the receive direction, so to speak. I think everything up to that fits very well in. I don't recall which terminology we've decided to use, but it's all the same BOW phi. It's just perhaps variants inside the of wire order and so on and so forth. But I think all that stuff fits pretty gracefully. And that's not to say that if we decide to do a single clock in both directions, that couldn't be under the bow umbrella. But yeah, that has its own whole set of electrical specs and timing specs and so on and so forth that will be a noticeable delta. Not that the others are not noticeable, just they're I should say a more noticeable delta.
So if you do create a mode that isn't interoperable, do you call that a new phi, or do you just say here's a mode interoperability chart and you go figure it out?
Only to only to try and translate the question, just because I guess I'm at the moment stuck in the detail. Is the quote unquote non-interoperable thing sort of this single clock, or did you have something else in mind? Basically what I was attempting to say was that I think for everything up to the single clock, okay, again, minor exception of where the clock bumps are actually placed, but let's ignore that for a second. I think for everything up to that point, it's pretty interoperable from a sort of basic perspective. Again, clock location thing. It's not that you couldn't make an interop; it'd just be uglier.
So so I guess maybe I can interject, but given the flexibility of bits is not as interoperable with the old stuff, like even if you assume we have the two, like one option is like if we want to make this go faster is to have a pair of clock going both ways in the middle, or however, but it's because we can individually control the bits. I think it's
you're absolutely okay. You're correct. But I guess I should clarify what I meant. I meant that those are all things that if you had that functionality, I believe it'd be fairly straightforward to just operate it in the way that was implied by the existing specs and make those two things talk to each other. That's what I was attempting to say.
Got it. So I guess in that scenario, even if we have one-way clock, we make the other one just to be a receive, and in that condition, it's still compatible, more or
Correct.
less.
Yeah, exactly. It would be sort of half compatible or whatever. Yes, that's right.
Yeah, so I mean, depends on definition of compatibility, but it
Yeah, no, totally, totally
yeah,
agreed.
which is a
Yeah,
weird definition in general. It's hard to clarify compatibility, but yeah.
yeah, no, totally agreed.
So
I mean,
I do have one. So this, if you go back to somebody had a bump map picture of the bow, right? The one with the clock in the middle and 8 on either side. Yeah, so the first one, on the first slide number 5 or 6, either one. So the question I have is, wait, this is the clock in the middle. Okay, current half. No, where is our original 16-bit thing?
By the way, just one small side note before we move on, because I know somebody else in my team noticed it, and I'm seeing it here too. I think we do have a typo in the image on the right over there. The CK plus CK minus in blue on the RX, I guess, are supposed to be D4 and D5.
Yeah.
Yeah. I think it was corrected in a different slide deck, but it's
No,
turned its ugly
no,
head
this one
back
is
in.
actual spec problem.
Yeah,
The
no,
spec
exactly. I think
itself
that
is a bug.
typo snuck into the spec.
Yeah.
Yeah. We talked about it that we maybe Shahab actually intended to have the clock in the middle. We joked about it a couple of like a month ago. Anyway, I think in the bottom one in the slide 6 you have the 16 bits. So the one on the
Yeah.
16 bits
So
present there.
why wouldn't we just enable an arbitrary number of rows from 1 through 4 symmetric?
Number rows 1 through 4. Sorry, do you mean
No, columns.
columns around the
Columns.
clock?
I mean columns. Excuse me. Like if you just you can either go 2 for 4, 8, 12, or 16
I
as long
think
as.
that's how should I
That's
say this?
that's what we're proposing.
It's all roughly the same when you're talking to 16-bit, but when you're talking to yourself, it matters.
I see. That's why you couldn't allow it. Okay.
Sorry, go ahead, Ahmad and Kash.
What do you mean by
I don't know
talking to
what you
yourself?
were talking about.
Okay.
Oh, it was more. I just want to know why we needed to specify an actual number of bits. Why couldn't we just allow any symmetric number of bits around the clock?
Well, the original thing is actually asymmetric, right? But
Well, no, it's at least in the 16-bit. It's in this. If you're going to go propose a symmetric around the, why do you have to do 8, 4, and 4 symmetric? Couldn't you should be able to allow any arbitrary symmetric number, right?
Yeah,
I
it
see.
does.
So
This is
maybe I misunderstood. Yeah, okay, I got it. Yeah.
yeah, because anything can be RX or TX, right? In theory, right? Although you would do it in blocks, but yeah.
I think when we started this discussion, like a while back, when having something smaller, there was, at least in the set of people present then, was questioning just the utility of having something smaller in general. And then basically once you take that a little bit more serious, like let's say once we say, okay, we're going to do any symmetric version, like basically from x2 to, or like from 2 bits to 16 bits, then how do you define interoperability if all of these become a possibility? And do you then have to start out like drawing out matrices of this can work with that? Or can you find easy rules that kind of describe that entire space with just a few kind of guiding principles? And I think that's where we decide, okay, well, since by 8 was already drastically cutting the beachfront in half and enabling like a separate space, let's like focus on that, because then it was a lot easier to think through the problem rather than just going to this generalized statement, which has a lot more corner cases or possible corner cases that you have to catch. But I do agree that it's interesting to like give like if you can indeed find a way to describe it neatly and anticipate problems of interoperability of some, like say a by 6 that wants to talk to a by 12 or a by 8, like how do you go about doing that? And if you can find a way for that, then sure, it would definitely be the more broader use case and allow more flexibility.
Yeah. And the other thing is like, let's say, as it says, talking to itself is what I guess Elon was talking about. So if you look at the slide before this, so if we have a by 8 talking to by 8, now and we have a single clock as an example, having the clock in the middle makes a difference versus being in the side, because when it's on the side, for our case that we want to have some flexibility, you have to have a distinct RX and TX. But with this case, you can have them sort of be the same footprint of files. That does make, that's I think what Sila was saying about like talking to itself sort of helps to have it in the middle for when we do want to have the flexibility in choosing RX and TX. Like if you rotate a file that has clocks on one side, again, if it's on two sides, that's a different story, but only on one side, you flip it around, it's not gonna line up. And that was one of the reasons for these flex option, we want to go that route.
Yeah, I guess that's why the wire order for the like RX and TX slices was defined that they come from either end, I think, and that then solved the problem. That it was always assumed you have an RX and a TX, and then if you turn that that stack around or that link that has two stacks, then that does always line up. But now if you want to achieve the same thing with just one slice, then yeah, that slice by itself has to be rotation symmetric.
Exactly. So that's for us, because we have to do that. We want to make rotation symmetry. Yeah, there's benefits and other things we can discuss. And that's why we want to separate it. We say, well, if there is somebody who are already doing it, we don't want to interrupt them. We want to have these as an alternate mode.
I mean, I think that comes back to what Elad and also Bobby were saying about like how different is the different directions within one slice from the spec that we have so far. And I think like back to Bobby's questions on should that be a different phi or not, I would personally probably would call it a, like, even if you call it say like a bow flex option or something, like then you could say that bow flex is backwards compatible with bow, but bow is not, but like a standard bow implementation is not compatible with bow flex unless it itself is a bow flex phi.
Yeah, but then so a derivative is backward compatible, but the original spec isn't forward compatible. Whereas for modes,
exactly,
you're making the old spec also forward compatible with the mode.
Yes, exactly.
So symmetric versus asymmetric compatibility. That's the difference between a mode and a derivative.
Okay, then I guess then but then for
no, not symmetric as in this layout. I'm just talking about symmetric the compatibility symmetry, not the layout symmetry.
No, exactly. No, I think that's described well. And if you take that as a guideline, then I think it's clear that it's a derivative rather than a mode, because if you take an existing bunch of wires, 16 bit phi implementation, there's no way they'll be able to retrospectively have data going in two directions on one slice.
Yeah. So I think it's basically this bow flex is backward compatible, but bow is not forward compatible to bow flex, which is, I guess, sort of valid for most things, right? So if those two are connected to each other, they'll connect through.
Should we hang our hat on that definition? Let me ask Ram, because he needs to be a victim.
Mm-hmm.
So a mode is something where Shahab's here. Okay, good. Then so a mode is, if I understand the proposal correctly, the difference between a mode and a derivative is backward compatible, but the base spec is not forward compatible to the derivative. A mode is where the base spec it can somehow, you're adding a feature where the base spec can also acquire it in some sense. It's kind of flaky, but somehow there's a path to symmetric compatibility.
Can you say that again?
If I understand it correctly, when you make a derivative, a base spec cannot be made forward compatible with the derivative. But then I don't know how you do interop if you cannot do so something like what that doesn't add up. If you if it cannot be forward compatible with the derivative, you can somehow do an interop, but it's not forward compatible. Is that a workable definition?
I think so. It basically just assumes like the derivative like can conform to where it came from, but the original phi, because it didn't know of the new features, is just not able to use the new features, and for that reason, like talk to a device if it's trying to use its new features.
Oh, I see. So it's okay. It needs some thinking. Somehow you can't retrofit the new feature onto an existing file. You'd have to fundamentally change it. That's the key thing.
Right. And so if you take so if you let's assume you have an FPGA that has a Bowflex interface, like you can still put like another bunch of wires chiplet onto it, and you'll just tell the Bowflex act like a Bow 1.0 or Bow 2.0. But if you like take like say an edge device that has a Bowflex interface and you put it on an FPGA that only supports Bow, then it will just fundamentally not work because the IoT device will rely on the Bowflex definition. And if it only has one slice, there is no way it can like go to an older definition to make use of like the previous spec.
I thought it was clean, but when I played back, it's confusing.
Yeah, well, I think we show that the half link does connect to a regular
Yeah. So
RX and TX. So I think it's not efficient, right? Just like the 8-bit isn't efficient, right?
No, but that's
Yeah,
that's like assuming like take the corner case, in which case you only take one phi, like one Bowflex phi, and one Bowflex slice, and you try and you're banking on the fact that you're going to do RX and TX in one slice, and you want to hook it up now to an existing host device that needs fundamentally two slices to make that work. How would you wire it up? And that, I think that's not a given right now.
Yeah. There's something in your definition, Marek. I get what you're saying, but it's the means of expressing it correctly. But I believe you're on the right track.
For what it's worth, I think I understand it and I think it makes sense.
Yeah, I think it sounds right.
In my opinion, I think you can make things backward compatible, but I didn't get the part where we are trying to also make things forward compatible, meaning say we have an existing 32-bit phi and with clocks in the center, and if you want to connect a 16-bit phi to that, the 16-bit phi would have clocks defined within its center, right? So the only way to connect today is basically to connected centered around the clocks, I think, but I don't think that's how Bow 1.0 specifies stuff. So I'm not sure if we can even have a backward compatibility mode here. Unless I'm seeing something. I mean, yeah, this is way too confusing to me. Yeah, I mean, we have always found the need for more slices rather than go half slice or quarter slice. So
Hey, since we're at 10 a.m., should we pick this up in tomorrow's meeting? It seems to be relevant. Should we pick it up in a link layer meeting? This whole mode versus derivative? Asking.
I think I'm not sure I can make that meeting. Tomorrow's meeting is Thursday, right? Yeah.
Tomorrow at 9 a.m.
Yeah, but yeah, I think it's a good idea to think it through. Maybe Ahmad can join that if you have time.
I think I have the same. Oh, actually, no, I can join it.
Yeah, let's spend about 30
9
minutes on it. I have a hard stop at 10 right now, so I've got to hop off.
Okay.
But if we could pick it up, Ram, tomorrow is good, and then tomorrow's 9 a.m. meeting.
Okay.
I have a conflict there, but I can drop what I meant and then like maybe send this to you guys and then you can discuss it.
Yeah, well, if you can, please join the back half or something.
Yeah.
Maybe not push it for tomorrow. Maybe we can sort of, if there is concerns, maybe we can just gather it for next week and just have it. I don't know if there's a way of sort of gathering all the
Yeah, it's
concerns
not
together
relevant to
rather than just
Friday.
pushing it
So
tomorrow for tomorrow.
Yeah, Marek, if you can just write up what you said, and then we can draw a response or some other idea, right? So then we discuss it next week. I think that makes
Yeah.
perfect sense.
Yeah.
All right,
Yeah.
Okay.
perfect.
And I think either way, no
Yes.
matter which way
hey,
we
I'm
decide, if
gonna
it's
drop, guys.
yeah.
JP, you're the host. Sorry.
No, that's okay. I was
Yeah.
just gonna say that no matter which way we decide, if it's a mode or like a new, like a derivative, like either way, I think this is a good idea. And the question is just like basically how compatible do we want to make it? Because I
Right.
think the last
Right.
time we talked about it, like 4 weeks ago, you always emphasize the fact that like, yes, you can play with existing a bunch of wires implementations and that, but that is a given no matter how we want to like work it out specifically.
Yeah. Okay. That's
right.
fair enough.
Okay.
All right. Thanks,
let's talk about
everyone.
it next week.
I got to run
Thank
as
you.
well.
Bye.
Okay,
Okay.
bye.
Bye, everyone.
Thanks, everyone.
Hi, Trent. Good morning. Hi, Ahmed.
Hi, JP. Hi, Ahmad.
How are you?
Doing well. How are you today?
I'm good, thank you. So let's give a few more minutes, couple of minutes for others to join. I don't know, Boppy is joining. And Tarun may join as well. Let's give him a minute.
There's Tarun.
Hey, Tarun.
Hey JP. Hey Trent.
Yeah, good morning.
Morning.
So let's get started. I don't know if Boppy is going to join today. And so I want to update. Last week I mentioned about the request to Facebook Meta. I haven't heard back from that mechanical team manager yet. I sent him a note. I asked him for his email address so we can communicate to him or his official email ID, but I haven't got back to him yet. I'll probably wait for a week and ping him again. And also, I haven't heard back from Blue Cheetah guys. I don't have the email address, but spoke to them over the summit, and at least Blue Cheetah guys should be interested. So let's say I'll find out more of where they are. Yeah, so I don't have any updates on what I talked about last week on getting more people on board on the mechanical and the design side. Right. So yeah, Trent or Tarun, do you have anything to add more?
No JP, I don't have any updates. The only thing on my plate was like I wanted to add a picture of one of the FPGA boards,
Sure.
but
Yeah.
that's I still like my colleague is like it's I think he's on vacation. I think or he's traveling for a project. So
Okay.
yeah, I'd like once I get that I'll add the picture. Other than that,
Okay.
I don't have any other updates.
Sure. Tarun, so you in your FPGA implementation, you have multiple cards, right? You have baseboard, and then you have the DIM kind of cards you can plug in for expansion, right?
Yes.
So would you be able to open source all the designs, like the baseboard as well as this the side DIM card? SODIM, right? The SODIM
yeah,
form factor, correct?
yeah. The FPGA board is an SODIMM form factor. So from when I spoke to Marcos, who's my colleague, so he said like it's they will be happy to open source it. So right now it's like a team from LBR and a team from Formulab designed it, and basically you can buy the boards from them for like around like $900 or something. They'll just like they have the designs, just fabricate it, depending on availability of parts and stuff. But I'm sure like, they were open to the idea of just giving us the designs and then giving us the layouts or Gerber files so that like we can fabricate it ourselves.
Okay, sounds good. What do you use that for, the DIM card for, the SODIM for?
So basically the FPGA board is general purpose, but like it's mostly used at like cryogenic temperatures where they have like other like custom ADCs where the data where basically the so I think like from what I understand, they have like a helium liquid helium tank where they're trying to like detect data, and then they use custom ADCs and this board, like basically the FPGA board connected together on a motherboard, and then they immerse everything inside liquid helium. So it basically goes to millikelvin and it works at millikelvin. And then they send power and everything from outside the chamber, outside the divert, and then they get the data. So this board was designed to work at cryogenic temperatures, and basically the main purpose was to use it with an AAC so that you can capture data.
I see. And what do you implement on that board? That SODIM board?
So the board is extremely simple. You just have because they want to make sure this FPGA works at like a millikelvin. They didn't have like LDOs and other active circuitry on the SODIMM board. They just have the FPGA, Arctic 7 FPGA, which actually works at millikelvin without any issues. So what they do is like they send external power, and then the other the custom ADCs capture the data and then like transfer the data to the ADC, and they use Ethernet connector to stream out the data using the FPGA.
I see. Okay, Tarun. I think that the concept looks interesting. I think we need to sync up with Boppy on and how we can progress further. He said he will set up a meeting with the other vendors as well who would be interested. Right. I'll talk to him and see if where he's at. Right, evangelize this concept. I think it'll be good to have more support so that we can define a common platform. Yeah, thanks to Trend, we have support from NXP, but having few more people on board would be good as well. Trent, do you want to add anything?
No, nothing to add. I'm hoping to learn, what the outcome was, or if you've completed discussions, JP, with Boppy and some other people as far as contributions to the system, so that we can finalize the plan for the mechanical design and building the boards and that type of thing.
Right. No, I haven't heard back from Boppy and the plans. I'll ping him next week. Maybe I'll request him to join so that we can formulate a consolidated thing.
Okay.
Okay. In that case, I don't have anything further to add. Let's wait for Boppy, and then we can go from there.
Okay.
Okay. Thank you, Trent. Thank you, Tarun.
Yeah. Thanks, JP.
Thanks, Tarun.
Yeah. Bye. Yeah. Bye.
Bye.